Boys and girls, in this second video, we are going to focus on subtopic 8.2, constructive interference and destructive interference. What is interference? Interference is defined as the effect of interactions between two or more waves which overlap or superpose at a point and at a particular time from the sources. So when two light waves that travel, they overlap at certain point, then we say we have what we call interference. Interference occurs. So guys, what happens when we have interference of light? So when two light waves meet at a point, a bright or dark region will be produced in accordance to the principle of superposition. So according to the principle of superpositions, when we have interference occurs, we might observe whether a bright or a dark. So what is principle of superposition? So according to the principle of superpositions, the resultant displacement at any point is the vector summations of the displacement due to the two light waves. Means that the resultant, the combination displacement for the two waves always is the vector summation of their individual displacement. So basically, we are going to have two types of interference. We might obtain constructive interference or destructive interference, as teacher shown here. So you will notice that we have two light waves. One is I represent with red color, another one I represent with blue color. So you will find out that if the two waves, they overlap each other and during their overlap, they are in phase, then we will find out that the amplitude will be double up. So we call this one as constructive interference. But there are times whereby the two waves, when they meet, they are out of phase. They are out of phase. So the trough for the red wave overlap with the crest of the blue wave, so their amplitude will be cancelled out. Why? Because one is negative amplitude, another one have positive amplitude, so they are cancelled out each other. Then we call this one as destructive interference. So get the ideas, huh? Then class, there is a very important terms that we must know in this topic, that is coherence. What is meant by coherence? Coherence means that the sources must have the same wavelength or frequency, and then the sources must have a constant phase difference between them. So the constant phase difference is the key words for coherence. So for any light source, they must have a constant phase difference. Then only they are considered as coherent source. For example, for the light bulb below, shown below, for the light wave that emit from the light bulb, you find out that there are no fixed relationship between the phase for all these waves. So we consider this one as non-coherent source, even though they might have single frequency. Okay, so what about the laser light? If you notice that all the waves that emit from this laser light, they have a well-defined phase difference between the wave. All these waves always have a constant phase difference between them. So this is what we call coherent light source. Okay, so this one is what we call coherent. So basically, we have two types of coherent sources. We might have in-phase coherent source or anti-phase coherent source. So how I'm going to distinguish in-phase and anti-phase coherent source? So maybe we show it with this figure. So a coherent source is considered as in phase if they both have the same starting. Their starting is the same. For example, this one, the S1 and S2 both are start with crest. So their starting point have no phase difference. They are the same. This one is start with crest. This one also start with crest. So there are no phase difference between the two sources. Then we say that one as in phase coherent source. Alright. Then we have another one we call antiphase coherent source. What is meant by antiphase coherent source? So, antiphase coherent source means our S1 might start with crest, but our S2, the second source, is starting with trough. So, between crest and trough, there is a difference of lambda over 2. I repeat, between crest and trough, there is a difference of lambda over 2, or is equivalent to 180 degree or pi radian. So class, if our two sources have a phase difference of pi at their starting point, then we consider that one as antiphase coherent source. Class, there are certain conditions in order to obtain a stable interference of light. Permanent or stable interference between two light sources can only take place if the two sources is coherent. It means that they must have the same frequency and always in phase with each other, or they must always have a constant phase difference. Second, the sources should be monochromatic. Monochromatic means they are consist of single wavelength. Number 3, light waves that are interfered must have the same or approximately of amplitude in order to obtain the total cancellation at minimum, so that we can observe a dark fringe, or to obtain a good construct as maximum, so we can obviously observe a bright fringe. 4. The distance between the coherent sources should be as small as possible of the light wavelength in order for us to obtain a permanent or stable interference of light. So this is the 4 conditions for the permanent or stable interference of light to occur. Coherence, monochromatics, same or approximately of amplitude, and the distance between coherent source should be small as possible of light wave. Then class, we have another concept we call path difference. I denote it by delta L. So what is meant by path difference? Path difference is defined as the difference in distances traveled by two light waves when they meeting at a point. So, for example, this one, I have source S1 and I have source S2. So, S1 will travel a distance of R1 to reach point B. S2 will travel a distance of R2 to reach point B. So, you can see very obviously from the figure given, the R1 and R2 is not equal. And you can see that for S2, the light ray travel a longer distance compared to S1. So this is their path difference. See, this is their path difference, whereby S2 travel an extra distance if we compare it with S1. So, path difference have a direct equivalence to phase difference. We might relate path difference with phase difference. So, if you refer to this one, we know that one complete cycle is 360 degrees. That is equivalent to 2 pi. And when we for one complete cycle, we will obtain one wavelength. So, the path difference lambda is actually corresponding to a phase difference of 2 pi, okay? I repeat, the path difference lambda is corresponding to 2 pi. One complete cycle, 2 pi. So one complete cycle will have one wavelength, alright? Will have one wavelength. So that one is the relation between path difference with phase difference. So class, why we must know about the path difference? So path difference will decide whether we obtain a constructive or destructive interference when they arrive at a point. So at point B, are we going to observe a constructive interference, or are we going to observe a destructive interference at point B? It will be determined by the path difference between these two light sources. Okay, so class, if we have two light sources, the path difference between the two light sources when they meet at a certain point will determine whether we obtain a constructive or destructive interference. For example, at point C, at this point C, the two light waves will meet in phase and they are going to have a constructive interference. As I change the position where they meet, observe what happened. So you will find out that there is a point whereby they will cancel each other, where the point A and point B, when they reach at this particular point, they are out of phase and they are cancel each other. So whether we obtain a constructive or destructive interference at a particular positions, it depends on the path difference between the two light sources when they meet together at that particular point. So how we calculate path difference? So path difference is given by the distance of the second source minus the distance traveled by the first source. So we have S2B minus S1B. So calculate the path between the two light sources. For example, S1 we have 1, 2, 3, 4, 5, 6, 7. So R1 is equivalent to 7 lambda. Here goes for S2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So R2 is equivalent to 9 wavelength. So how I find the path difference? So the path difference between them will be 9 lambda minus 7 lambda equal to 2 lambda. So this is how we find the path difference for two light sources. So class, what is the condition for constructive and destructive interference to occur? So if we have two light sources, S1 and S2, which are coherent source and start in phase, their starting is the same, and then they meet at point B. So we will find out that in order to obtain a constructive interference, a bright light is observed at point B. Their path difference must differ by an integer number of wavelength m lambda. The two light waves will arrive at B in phase and they will give rise to a constructive interference. And then we will have a darkness is observed at point C if the path difference is differed by a half integer number of wavelength. So if the difference between the two paths travel, when they meet at a certain point, for example point C here, if their difference is in the half integer number, means half wavelength, their difference is half wavelength, then we will find out that the two light waves will arrive at point C out of phase and give rise to a destructive interference. So this is the condition for constructive and destructive interference. But we have to bear in mind, not all sources are always in phase. We might also have two coherent sources, but their starting is out of phase. Their starting is out of phase, whereby at starting point S1 and S2 have a phase difference of pi, which is equivalent to lambda over 2. Our S1 is start from crest, our S2 is start from trough. The difference between crest and trough is equivalent to lambda over 2. So, this initial difference between the two coherent sources we need to take into consideration when we want to write the condition for constructive and destructive interference. So, when we have two coherent sources which are start out of phase and dephase, then our constructive interference condition will become the path difference equal to m plus half lambda, whereby we have to take into consideration the initial difference between the two coherent sources and then add with their path difference when they travel and meet at a certain point. Then this one will equal to the condition in order to have a constructive interference. So if we rearrange these equations, then we will find out that for the coherent source which start out of phase, the path difference must equal to m plus half lambda in order to obtain constructive interference. Same goes for destructive interference. So we have to take into considerations the initial difference. So we add it up with the path difference, then only we equal to the condition for destructive interference. So when we rearrange, we will find out that the path difference will equal to m lambda in order for a destructive interference to occur. So I summarize it in a table. So basically, we have two coherent sources, whether it's in phase or antiphase. For in-phase coherent source, in order to obtain constructive interference, it means that we observe a bright or maxima, our path difference must equal to m lambda, whereby the m is what we call order number, starting from 0. 1, 2, and so forth. And in order to get destructive interference, a dark or minima, our path difference must equal to m plus half lambda. The m is the order number, so if our path difference is in the difference of 0.5 lambda, 1.5 lambda, 2.5 lambda, 3.5 lambda, then we will obtain a destructive interference. Okay? Then, if our source is antiphase, if you have antiphase coherent source, then in order to obtain a constructive interference, our path difference must equal to m plus half lambda. It means that if the path difference between the light ray is in the order of 0.5 lambda, 1.5 lambda, 2.5 lambda, then we will obtain a constructive interference. But to obtain a destructive interference, for antiphase coherent source, the path difference must equal to m lambda. It means that if your path difference between the two antiphase coherent sources is lambda, 2 lambda, 3 lambda, or 4 lambda, then we will observe a destructive interference. Okay, so the conditions for constructive and destructive interference is much more depends on whether our coherent source is in phase or antiphase, and also the path difference between the two light sources when they meet at a particular point. Okay, when they meet at a particular point. So when they meet at a particular point, when they satisfy this one, they will obtain a constructive interference. If they satisfy this one, then they will obtain a destructive interference. Alright, so this is the summary of the condition for constructive and destructive interference in light.